Hello everyone, this video is about Chapter 8, Hypothesis Testing. Firstly, what is hypothesis? Hypothesis is a claim or a statement about a property of a population. Different people will have different claims about the population. For example, one student may have a claim that our school student average age is older than 21 years old, versus an instructor may have a claim that our school student average age is younger than 21 years old. What is hypothesis testing? That is, to test the claim or statement. Do you have sufficient evidence to support the claim or a statement? Now, let's introduce how to do hypothesis testing. Here is the procedure. Firstly, we need to frame the non-hypothesis and alternative hypothesis. Then, specify decision rule or the rejection region. After that, take a random sample of the population. Then determine the test statistic. Lastly, make the decision. Let's see one by one. Let's see the first step. Frame non-hypothesis and alternative hypothesis. We write HA for the alternative hypothesis, which involves the claim to be tested. The non-hypothesis is written as H0, which is the opposite of the alternative hypothesis, which is also a status quo. So we need to translate the claim to numerical values. In this class, we will only discuss the hypothesis about the true mean mu or the true proportion p about the population. Our textbook simplifies the question. That is, you only need to write H0 as equal to. HA involves the claim. If the claim is that the mean or the proportion is less than, we write as mu or p less than. Similarly, if the claim is that the mean or the proportion is bigger than, then we write mu or p bigger than in HA. Lastly, if the claim is that there is a difference or equal to a number, we write not equal in HA. Note that this is a special case. If the claim is that you want to prove mean or proportion is equal to something, we always write not equal in HA. So there are the three possible forms of the hypothesis of H0 and HA. For the first two cases, smaller or bigger, we say it is one-tail problem. For the last one, not equal, it could be smaller or bigger, so we call it two tails case. Let me show you an example. In this example, we have two claims. Let's set up one by one. According to Journal of Advanced Nursing, more than 45% of senior women use herbal therapies to prevent or treat health problems. In this statement, the key word is more than, and it is the proportion P, not the mean. So in HA, we write P bigger than 45%, 0.45, which involves the claim in this question. HA you can always write as equal to, so it will be equal to 0.45. 0.45 here is the hypothesis value. The second sentence, of senior women who use herbal therapies, they use an average of 2.5 herbal products in a year. In this claim, it seems no keyword like more than or smaller than, so it should be the third case, not equal case. We always put not equal in HA, no matter you want to prove something equal or something different from. And also, it is about the mean. We write as mu not equal to 2.5 in HA and mu equals 2.5 in H0. Here are some language hints for you which may help you to frame H0 and HA. For one-tail problem, bigger or smaller, such as greater or less, more or below, and so on. For two tails problem, some keywords such as equal, exactly the same, not changed, change, same as, compare, or different from. We always write not equal in HA. Now let's see the next step. Specify decision rule or the rejection region. H0 is a rejectable hypothesis. There are two possible decisions of this test. Reject non-hypothesis H0 or do not reject non-hypothesis H0, or you can say accept H0. H0 and HA, only one statement is true. So if you reject H0, it means you support HA. However, sometimes we may make some wrong decision and it will cause some error. Type 1 error is when H0 is true, but you make a wrong decision that you reject it. The error we call type 1 error. Similarly, if HA is true, but you make a wrong decision, you accept H0, it will cause some error which we call type 2 error. In our class, we will only focus on the type 1 error. Usually, we denote type 1 error as alpha. Usually, it is given. We hope this error is small. Some common alpha we allow is 1%, 0.01, or 5%, 0.05, or 10%, 0.10. Alpha also has some other names. It is called type 1 error, also called as rejection region or significant level. Because alpha is a probability that allows for the error, So alpha, which is also called rejection region, is a probability. As we learned before, probability will be an area. So rejection region is an area, as shaded. For the case HA, smaller than will be on the left side. This shade area is rejection region. For the case HA, bigger than, this shade area is rejection region. Bigger than, it will be on the right. For the third case, HA not equal, it will be both sides. The two shaded areas together are called rejection region. For each shade area, the cutoff. Those points in red we call critical value. So we need to find out what is the critical value. Please watch the other videos of finding critical values. Next step. Take a random sample of the population and determine the test statistic. Here we have 3 different cases, similarly as Chapter 7. Case 1, large sample means problem, where n is bigger or equal to 30, and we use z-table. Case 2, small sample mean case, where we use t-table. And case 3, large sample proportion case, where we use z-table. Let's see case by case. Case 1, when n is bigger or equal to 30, how to calculate the test statistic. The test statistic will be a z-score equal to x bar, which is the sample mean, minus mu0, which is the non-hypothesis value, which is the number in H0 and HA, and then divided by sigma, the population standard deviation, and divided by the square root of n, where n is the sample size. However, most of the time, sigma is unknown. So we use S instead, where S is the sample standard deviation. Now let's see the case 2. When sample size is smaller than 30, we will use t-table instead. The test statistic will be a t-score then. The formula is like this, where x bar is the sample mean, mu0 is the non-hypothesis value, the number in H0 and HA. S is the sample standard deviation, and n is the sample size. We will use t-table to find out the critical values, and the degree of freedom is n-1. Case 3, the large sample proportion case. The test statistic will be a z-score. The formula is like this, where p hat is the sample proportion. P0 is the non-hypothesis proportion, the number in H0 and HA. N is the sample size, the total number in sample. After calculating the test statistic, we need to make a decision. whether you reject H0 or not reject H0. How to make a decision? If the test statistic falls in the rejection region, reject H0. If the test statistic is outside the rejection region, do not reject H0 or we say accept H0. This is one method to make a decision using alpha and critical value. Here is another method to make a decision using p-value and test statistic. So, what is p-value? The definition of p-value is the probability in the tail associated with the test statistic. So p-value is probability. Probability in the curve plot is area. I will draw the curve for you to understand the concept of p-value. How to find p-value? You need to see the HA first. If HA is smaller than, where the area will be on the left side. No matter your calculation of test statistic result is negative or positive, starting from the test statistic result, highlight everything on the left. That area in yellow is p-value. Similarly, if HA is bigger than, you need to highlight everything starting from the test statistic result to the right. So, the area in yellow is p-value. Lastly, if HA is not equal to, it will be two-sided. So after you calculate the test statistic result, symmetric to the other side and highlight the two-side areas. The area in yellow is p-value. How we can make a decision? If p-value smaller than alpha, where alpha is always given, then reject H0. If p-value is bigger than alpha, then do not reject H0 or accept H0. In summary, we have learned two methods to make a decision. That is, reject H0 if 1. Test statistic is in the rejection region, or 2. P-value is smaller than alpha. Otherwise, do not reject H0, or you can say accept H0. After making decision, it is better to interpret the decision. How to interpret? If the decision is reject H0, we can say that at alpha equal to which percentage, there is sufficient evidence to indicate that claim in HA. If the decision is do not reject H0 or accept H0, we can say that at alpha equal to which percentage, there is not sufficient evidence to indicate the claim in HA. Please watch the other videos to learn how we can use z-table and t-table to find out critical values and p-values. That's all for this video.